All right, guys. So in this unit, we're gonna be looking to learning how to solve systems of linear equations in three ways. The first one being through graphing, the second one through elimination, and then eventually through substitution as well. So in this video, we're gonna be diving into just graphing. So I do have three different situations of the ways that you could potentially see them in our unit, right? And it will depend on whether we see it in standard form, which is ax plus by is equal to c, or in slope intercept form, which is y equals mx plus b. And if we look at the first two equations, these are already solved for y, right? So something similar to the second one. We already have mx, right? So something multiplying by x, and then just the constants, right, which would be the b's in this case, right? So both of them already are in slope intercept form. So I'm gonna make this my blue line, right? So I'm gonna have y is equal to 2x minus 5 in this case, and if we remember, the m is the slope, right, and then the b is the y-intercept in this case, which is where we start. So if we look at this problem, in this case, 2 is the slope, right? So we have the slope at 2, and in this case, the y-intercept, right, is a negative 5. So we get the y-intercept to be a 0, negative 5, essentially, right? Because that's where it's going to cross the y-axis in this case, right? So the other thing that we have to know when we have it in slope-intercept form is that when we have a positive slope, we're going to do rise over run. And when we have, or it could also be negative, right? A negative slope, and that would be a fall over run. Okay, so depending on what we have, it's what we're going to use. So in this case, the slope was positive 2, right? So the slope was positive 2. So that means that it's going to be a rise over run. So I could just make this into a fraction since I do need a rise and a run, right? So in this case, the 2 is the rise divided by the run. So then the first thing we're going to look at is, well, what's the y-intercept? Because again, that's what it's going to tell us where to start. So in this case, we're starting at negative 5. So we got to be careful. So we're going to go down in the coordinate grid, and that should be here between negative 4 and negative 6. That's negative 5. But then we're going to have a rise over run of 2 over 1, right? So we're going to rise 2. From starting from the point, we're going to go up 2, 1, 2, and then we're going to run 1 to the right, and we're going to put our point. So that's all we really need is 2 points to make a line. But in this case, I'm going to add a few more, or let's say just one more, right? Rise 2, 1, 2, 1 to the right. So now I have quite a bit of, I have at least 3 points to kind of figure out in this case, where they're intersecting, right? So that one should be around there, right? So should be, and again, make sure that you use your ruler for that, right? The second equation is going to be my red equation, which is y is equal to negative 2/3 x plus 11. So in this case, now we could see that the slope in this case is negative 2/3, right? So negative 2 over 3. And then my y-intercept is at 11, right? Or 0, 11, right? It's a y-intercept. So same thing as the last one, but in this case it's a negative, so it'll be a fall over run, right? So this will be a fall over run, right? Sorry, that's a little. So fall over run, right? And we're starting at 11. So in this case, we're going to stop up here, right, at 11. And in this case, it was falling 2 and running 3. So I'm going to fall 2. So 1, 2, run 3. 1, 2, 3. So that would be my second point. And I'm going to do one more again. Go down 2, fall 2, 1, 2, run 3, 1, 2, 3. So it's actually there, right? So in this case, we're going to fall again. It was 2, run 3. 1, 2, 1, 2, 3, right? So in this case, we get that first value, right? And in this case, now we could create the line. Same thing with this one, right? Again, extend it the whole entire way. Make sure that all 3 points are connected. And then now that we graphed them, right? Again, now that we have them, now we have to find the solution. Well, the solution, if we think about the system's equation, is graphically we could see that as through the point of intersection, right? POI, right? So the point of intersection was where? Well, in this case, it was at 6, and the other value was at, in this case, 7, right? So the answer, the point of intersection would be at, in this case, 6, comma, 7, right? So the point of intersection was at 6, 7 in this case. Now looking at the next equation, right? So again, in this case, both of them were in slope-intercept form. So boom, boom, beautiful, right? But now we actually have a combination of equations. So in this case, the first one is in slope-intercept form. So we just did that. That's great. But then this one is in standard form, right? So this was AX plus BY is equal to C, right? So it's going to be a little different. So again, let's make this the blue equation. We kind of talked about this right up here with the slope-intercept form. Again, M is slope, B is the y-intercept. So same thing here. In this case, the equation is 1/2 x minus 3. So in this case, our slope is 1/2. We're going to go a little faster with this one because we've already done 2 of them on the top. So it's positive, so it's going to be rise over run. Perfect. And then what's my y-intercept? Well, my y-intercept for this one is at -3, right? So 0, -3. Perfect. And that's all I really need to graph it. So what's my starting point? Well, it's 0, -3. So down here between -2 and -4. And then I'm going to rise 1, run 2, 1, 2. Rise 1, run 2, 1, 2. Right? So now that I have those, connect the points. Right? And you, for your point, you should be able to make sure that you go from left to right, right? All the way down, all the way up. Now, though, this is the first time we're seeing an equation in standard form, right? So we have 3x plus 6y is equal to 30. And the main thing we have to remember is that when we have it in standard form, we're going to want to find 2 things. We want to find the y-intercept, and we do that by setting x is equal to 0. And then we're going to want to find the x-intercept, which is when we set y equals to 0 to solve for that value of x. So in the first one, if we're looking for the y-intercept, again, the equation is 3x plus 6y is equal to 30, right? That's what they give us over here, right? So now we're going to just substitute the value of x for 0 in this case. So we're going to do 3 times 0 plus 6y is equal to 30. Well, that cancels out, which is great. And we have 6y is equal to 30. Divide by 6 to both sides, we get y is equal to 5, right? So in this case, the y-intercept is a positive 5. So again, this is the y, this is the x. So the y was a positive 5. Now we have to find the x-intercept. So same concept, the only thing is that we're setting y is equal to 0 now. So we get 3x plus 6 times 0, or y in this case, is equal to 30. That cancels. We get 3x is equal to 30. Divide by 3 to both sides, we get that, in this case, x is equal to 10, right? So in this case, then, our x-intercept would be a positive 10. And same thing, once we have the 2 points, we just create a line using those 2 points, right? In this case. All right. We've created equations, right? And then now we're trying to figure out, in this case, right? And again, we gotta be very, very careful with these, right? Because otherwise, then it messes that up, right? So even this one, right? We have to be careful, right? With this one, right, connecting the points together. And then at this point, again, when we have it really secure, we could see that the point of intersection is actually at what coordinate point? Well, in this case, be at 8, 1. And again, the only difference is that now I had one equation in slope-intercept, the other one in standard form, right? That's really it on that one. And then, so in this case, then the point of intersection would be at 8, 1. That's the solution for that one. Lastly, again, what if we had two equations that are in standard form? Well, it honestly wouldn't matter, right? We just have to find the x and y intercept for both in order for us to do that. So the first equation is 2x minus 4y is equal to 24. And then the second equation is 3x plus 6y is equal to 36. Right? So same concept for both. First, we want to find the y-intercept. So we set x is equal to 0. So we get 2 times 0 minus 4y equal to 24. That cancels. We get negative 4y is equal to 24. And by negative 4, we get that y is equal to 6. Right? So again, that's the x-intercept. Now the y-intercept. So now the x-intercept, we set y is equal to 0. Right? To be 2x minus 4 times 0 is equal to 24. So that cancels now. And then we get 2x equal to 24. By 2, we get x is equal to 12. Right? So for the blue equation, in this case, right, the first equation, the y-axis, the y-intercept was a 6. And the x-intercept, the y-intercept was a 6, my bad. And then the x-intercept is at 12 in this case, right? So all we really need in this case, again, is make sure that these equations, these points are lining up correctly, and we're able to create the equation, right? So that was how we could graph this one, right? And again, I'm going to extend it from left and right, both sides, right? This could have arrows because it's going to continue going on both sides. Now for the second equation, again, I got to find that y-intercept by setting x is equal to 0. Right? So we get 3 times 0 plus 6y is equal to 36. That cancels. We get 6y is equal to 36. Divided by 6 to both sides. We get that y is equal to 6. But then to find the x-intercept, we set y is equal to 0. Right? So in this case, we get 3x plus 6 times 0 is equal to 36. That cancels out. We get 3x is equal to 36. Divided by 3, we get that x, in this case, is equal to 12. Right? So in this case, for the red equation, the y-intercept was a positive 6. Right? And so in this case, in this case, let me see, 3x. is equal to 6. And then 36 divided by... Let me see. Okay, so sorry. I know what I did wrong. So this one up here was negative 4y, right? So you see, even Mr. Rodriguez can make mistakes. That's fine. So actually this one, we don't have to redo it. The first equation was actually at negative 6. Sorry, I was like, wait, it's the same equation? That's so weird. But no, this is actually negative 6 for the blue one, right? That comes from here. I forgot that this was negative, so I didn't put negatives here, so my bad. But again, it also shows you guys that you guys don't, when you guys make mistakes, you're not the only one. So I'm actually glad I made this mistake. So in this case, again, that will go something like this, right? And in this case, we can go down. So just to extend it, right? Just so you could see it's an extension of that line. Just like that. The red one, again, that's how I tripped out, because this one's 6 and 12. But this one was actually positive 6. So that makes sense that it's positive 6. And then 12, right? So in this case, right? So we could just extend those lines, right? But in this case, we could see the point of intersection is at 12, 0. So again, my bad on this last mistake, but again, it reinforces for us to be careful. It happens to all of us, even your teacher, so don't feel bad. But just be careful. It happens, and hope that helps. Again, this was solving systems of linear equation through graphing. Have a great day.